All right, so we are looking at an animation of a Bendix air brake system here, and I want to walk through some of the basic operation. I'm going to try and keep this very short and very simple as an introduction to the air system and the air brake function in a vehicle. Okay, so we can see down here we have our air compressor itself. All right, through our air dryer, what we call our supplier, our wet tank, and then our secondary and our primary tanks are what is going to eventually feed the braking system. We're not going to get into all this complexity just yet. I'd like to focus on very simple operation for the time being. You can observe up here I've got a pressure gauge both for a primary and a secondary. That's why we have two gauges showing. For our purposes today, they will just move together. We will treat them kind of as one pressure gauge for the time being. Our dash valve is here. Okay. Our brake chambers on the back, these are our park brake springs here. They're activated right now, which means there's no air pressure in here at all in any of the system. The system's actually at 0 psi. So if I were to push in on this park brake, it would pop back out at me firstly, but if I were to hold it in, nothing would happen. So right now our park brakes are on. That means we have a mechanical spring here shown purple as this kind of cross section, these dots. That's meant to be a spring. It's acting on this little plunger right here, which then acts on the plate for the service side push rod assembly. That acts on the foundation brakes, which pushes out on the shoes and actually holds the drum. Okay, so this is the same basic operation, even if we're using an air disc brake. The concept here is the same. If there's no air in this system, a mechanical spring is actually pushing on the foundational brakes and the slack adjuster holding the vehicle in place. Typically, we would only see this on the drive axle. Okay, as well, you may see them, of course, on trailers. But when we're talking about the truck, just on the drive axle, we do not have a park brake system on the front. That would be extremely rare. Even on the drives, we may only see this on one axle, depending on the weight of the vehicle and its application. But most commonly, it would be this arrangement where on a tandem truck, we have park brake chambers on all of the drive wheels. Okay, so we can see without air pressure, we cannot release the brakes. So as a safety precaution and inherent in its design, that mechanical spring will apply the park brake anytime there's not enough air in this system. So let's go ahead and watch the compressor. We're going to start the engine up. The compressor is directly driven by the engine, and it should be building air. But of course, it's fighting me a little bit here. There's an issue with this animation. Let me reset it. Let's try again. So here we go. We're building air. The engine has started. The compressor's moving. Okay. And when we get to the cutout pressure of this governor, we're going to always be referencing this supply tank, the wet tank. There's a line that's going to go to a little governor, and there's a mechanical spring in there. And we can actually just see it happen very quickly. Once enough pressure is in this line, and this is a setting that we can adjust. They typically come preset, but we can adjust this a lot of times. This governor, that pressure in the wet tank will overcome that spring, which will expose a port in here that will then go to one of the valves. We call this the unloader port in the air compressor. And that will open a valve inside the compressor, and basically it's taking away the compression of this little mini engine. All right, so we've opened a valve, no compression's occurring. And therefore it's not going to build any more air pressure in the system. So once we reach our preset air pressure, and I can bring that down again just so you guys can watch it. So just kind of ignore what I'm doing up here. I'm just dumping the air out to get it back to a cut-in pressure, and you'll observe that there's no air going to that compressor. It's going to start pumping up again. And then once it gets to pressure, it's going to overcome in that governor and hit the unloader port, and once again we stop building pressure. So it all occurs very fast on this animation. All right, so we now have air pressure in our system. Okay, we can see that we're somewhere around, let's say 100 psi, somewhere in that ballpark. Not super relevant for us right now. Because we have air pressure, now we could release these parking brake. Okay, this parking brake. So let's go ahead and push the yellow button in and we'll see what happens. We can see air pressure is now being fed back to these valves, right? And then sent to each of the brake chambers on the back port, on the port farthest away from the slack adjuster. It's going to apply air pressure that's going to hold off that mechanical spring. We can see the plunger has moved back, and our return spring here inside the service side has forced it back. And now, if we were on a hill, this vehicle would be rolling away. Okay, there's no brake occurring right now at all. So I'll show that once again. We can see our push rods that are being pushed out by the mechanical spring. If we supply air pressure, that relieves that mechanical spring or holds it off, holds it backwards, okay, which allows the push rod to move backwards and the pressure to come off the slack adjuster and the foundation brake. So now the vehicle can roll. All right. Now, when we apply the brake, you may intuitively think we are relieving this pressure. That is not the case. The way that we apply the brake is different. So we treat our park brake system and our park brake circuit separately, and it is separate from the service application side. Okay, so we have air pressure that's going here. It's shown in yellow. Okay, it's actually a combination air pressure between the primary and secondary, depending on a dual check valve, which is something we'll get into later. For now, all you need to know, it is separate. It's just to relieve the park brake circuit. Okay, so we apply that pressure there, and it stays there during operation of the vehicle. It doesn't really get altered as long as the pressure in the system does not drop. This air pressure will just remain there until we go to park the truck and we relieve it. So when we step on the brake, what we're actually going to do is send air from a couple different circuits, and it's metered in a couple different ways we don't need to focus on right now. But we are going to step on this foot valve. It's going to mechanically allow some ports to open inside of its valve, inside the treadle valve. And then we get air pressure going out to the front brake chambers, which acts on the push rod and the slack adjuster, and as well on the back. So our park brake circuit, if you've noticed this already, again, is only going to apply a parking pressure to the drive axles, or the ones that have a park brake section. Okay. So here they're released. When we step on the brake, air pressure is going to be applied to our service pots. Okay, so to the front half or the slack adjuster side of these combination brake chambers. So we showed in green here. At the front it's shown in red. That's only because a different circuit is supplying it, which we'll get into later. But it's all supplied here. So if this pressure gets low, again, at any point due to consumption here, from stepping on and off the brake, if our supply circuit gets low, the governor will turn that air compressor back on, and it will start pumping again to get us back up to the pressure we need to be at any given point in time. If for some reason our air compressor stopped building or the engine was off and we start losing too much pressure, eventually our brake chambers will come on, so that park brake will come on. So if air pressure does get low enough, we will lose air pressure in the park brake, which will start to engage or turn on the brakes as a safety backup.